Okay, so on this one, we are trying to match each equation with a graph above. So I'm trying to graph equations with which ones are their graphs. Well, this is a good comparison. Let me give you some key and important facts. So an exponential function, is one that looks like this. Here, I'll just call it, it's got a base, an x, maybe plus some other number out there. So, and those graphs generally, usually, rocket up. They flatten out on one side, rocket up on the other. And the bigger bases go up faster. And then down below, let's do logarithmic graphs. So logarithmic graph is one of the form log base b of x minus a, like that. And those graphs, what they do is they just grow, they're slow growth. See how they're concave down? They're like a bowl turned down. Let me write you a note here. It'll help. It's a down-turned bowl. Oops, I keep changing my mind there. Okay, it's a bowl turned down. See how the log is like a bowl turned down? Whereas up here, this is like a bowl turned up. See that difference? Exponentials go up fast because they're like a bowl turned up, whereas logs are like a bowl turned down. So they're opposites of each other. So first off, we can see that both the red and the black over here are exponential. Right? Both these guys are there because they're both turned up, they're exponential. So it's 10 to the x and e to the x. Those are the exponential equations. The other ones are logs, right? Exponential means x is the exponent. It's in power. So see how x is in power and x is in power? Those are exponential functions. Okay, so well, which one's more powerful? Well, how do I explain this? If you know E, so that's an important thing too, if you're moving forward in math and science. You know pi, right? Pi is 3.14159, blah, 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 blah. Pi is a special number they use for circles and things, right? 3.14159, blah, 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 blah. Well, E is like pi. It's a special number. It's 2.718, blah, 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 blah. So you can get it on your calculator. So my point is E is a special number. It's 2 point something. That's all you need to know. So this is like saying, this one right here is like saying 2.7 to the x, and this one's 10 to x. So which one's bigger? Well, that one's bigger, right? 10 to the x is bigger. So which function, remember what I said up here, bigger bases go up faster for exponential. So which one of those is the bigger base? This one, up faster. 10 to the x is going to go up faster. The e to the x is going to go up slower. They'll both go up. They're both a bowl turned up. They're both exponential, explosive growth. They're both going up, up, up and away like Superman. But one of them's faster. 10 to the x is faster. It's going up faster than 2.7 because e is just 2.7. It's like pi. It's just a little smaller than pi.
Would it be the red one?
So what's that?
The red line
Is going to be which one?
10 to the x.
Exactly. Good. So the red has to be the 10 to the x, that's faster, and the black has to be the e to the x, doesn't it? So the 10 to the x is the red, and the black down here is the e to the x. Are we good so far? So those are the two exponential functions, and the bigger base goes up faster, 10 to the x. Now, let's look at the other two graphs. The other two are logs. They look like logs, right? They're bowls turned down, which is the inverse. You know, what is a logarithm? It's the inverse, it's the opposite of an exponential. As we can see from the graph, they're mere reflections of each other. So across the diagonal line, so you have the diagonal line, an exponential and a log are mere reflections across the diagonal line. The y equals x, diagonal line. They mere reflect, they're inverses, opposites of each other. So that's why logarithms were made up. They were made up to be the opposite of exponentials. Okay, well, anyway, which one's which? Well, yeah, I would just plug in some points, honestly. I mean, I can tell you some magic formula tricks, but you're not going to remember those. Let's just plug in. So I'm just going to say, okay, maybe I'll create a little space up here where I use this. I'm doing logs now. So I'm just going to create some space. And I'm going to say, okay, we have log of x. So we got y equals log of x. Now, hey, now there's no base showing. So the base is really 10, isn't it? Remember when the base is not there, it's an invisible understood 10. So, okay, so I'm going to make, now really, I'm not going to graph the entire thing. We could graph the whole thing. We just want to know which one is which one. Well, look, I'm looking it over. Well, I don't know, maybe I'm being too tricky with all of this. If you make an XY chart for it, I told you to first plug in what makes x 0, right? Always start with whatever makes the inside of the parentheses 0. Start with an x to make the inside of the parentheses equals 0. So that would just be 0. You get log base 10 of 0. You do that on your calculator, right? Remember how we do that? I'm just running out of room here. Log base 10 of 0. The base goes down to the bottom. It's going to be air. That's your vertical asymptote. No surprise. That's your vertical asymptote. And then you add 1. If you do that, you're going to get 0. I'll just tell you. I'm going to save some time. Boom. But that doesn't distinguish them. So now go to 2. That's where we're going to see the distinction. When you plug in 2, you're going to get log base 10 of 2. Y is going to equal. And then the base goes to the bottom. And hit the buttons on your calculator. I'm going to do so right now. Oh, you know what? We don't even need, what am I doing? We don't even need to. I mean, that'll work. That's true. But we for base 10, we can just hit the button, right? Y is log base 10 of 2. Just hit the button. I mean, you don't need to make it 2 logs. You only need to do that when the base is not a button you already have on your calculator. But that one's a button we already have in our calculator. Over 2 up 0.3. Okay, so that one's over 2 up 0.3. Let's try the other log function. See how that one goes. So the other log function, y equals natural log of x. I'm going to make an XY chart. Again, if you did 0, you get the vertical asymptote. If you did 1, you get 0. I'm going to jump right to 2. So I'm just going to go y is ln of 2. Again, ln is a button I have. So you don't have to do the fancy change of base, make it 2 logs thing if the base is already 10 or it's a natural log, because you have that button. You can just hit natural log of 2. And I'm getting 0.69 or 0.7. on that. Does that make sense? This log base 10 of 2. Is it the same as log 2? Here. Is it the same as log 2 over log 10? Yeah, for sure it is. But why bother with all that? Log base 10 of 2, you got a button. The regular log button on your calculator that shows no base means it's a base 10. So just use that button. You don't need to change it to 2 logs. We only have to change to 2 logs when it's some like log base 3 of 2. We don't have a log base 3 button. We're going to have to change that to 2 logs. And right? All right. I hope that made sense. So anyway, which one of these is higher up? This one. Over 2 up 0.7. The natural log is higher. So this one must be the natural log that's higher. This is the regular log that's on the bottom. So the natural log is higher. The natural log must be the green. Natural log must be the green. And the blue must be the regular log because that one's lower, right? 0.3 is lower. And 0.7 is higher at over 2, right? That's at over 2 up 0.7 over 2.3. So they're both over 2. One of them is up higher than the other. See that difference? The natural log one is higher up. So that's how we know which one's which one. There we go.